Good morning, students. In connection to previous topic we'll see today about a parallel circuit, the reliable workhorses of everyday electricity. And let us see about parallel circuit. Before that, let us recollect about what is serial circuit. It has a consistent current, ensures that same current flows through all the components, which is beneficial for certain application. Next thing is the voltage division. It distributes the voltage across the components, which has been useful for controlling voltage levels. And third thing is about the total resistance, which sums the individual resistance, which can be used to calculate overall resistance. And single point failures means the total circuit has been affected and the current has been passed through the entire circuit. So today let us see about what is parallel circuit. So imagine a highway with multiple lanes splitting apart from one point and merging back, which means the traffic flow across the point is freely move from one lane closes. Okay, so if any one lane closes, there is a flow of current through the circuit. So if any one line closes, the traffic in the road not be much affected, and so the parallel circuit connects across the same point between 2 points, creating an independent branches for the current. So the parallel circuit is a circuit where components are connected across the same 2 points and giving a multiple path for current flow. So that more than one path for flowing of electricity. See, by this diagram, you can easily understand there is more than one part of a flow for electricity flow. And continuation of that, current from the battery is divided among the branches like water splitting at Y junction, which means just imagine a Y pipe, Y type tube. So water is coming from one pipe and dividing into two bays. So each branch may have a resistor or a bulb and it gets a full voltage source but not handling current share. So the key players of minor series, that is voltage source, loads, but now it is a multiple path. Let us see the key properties between the current, voltage and the resistance. So the key rule number one is that voltage. So in parallel circuit, the V total is equal to V1 equal to V2 and V3. So the V total is equal to V1 plus V2 equal to V3, whereas in parallel circuit, the voltage is V1 plus V2 plus V3. So the voltage is same across all the branches and each components get fully supply voltage. Next, the key rule 2 is something that here the total current that is equal to the summation of current. Whereas in your series circuit, I total is equal to I1 equal to I2 plus I2, that is equal to I2. The current flow through the circuit is equal. So here the summation of uh, the current flow through the each branches, that is I total is equal to I1 plus I2 plus I3. So here the current split among the branches depending on the resistance, and also low resistive branches are have more current. Next, the key rule number 3 is the total resistance can be calculated as 1 by RT equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is the formula for calculating the resistance in parallel circuit. So in this circuit, the voltage, the resistor value is 2, 6, and 3. So based on this formula, it is calculated as this. So total resistance is parallel is less than the smallest resistor. So more branches, less total resistance will be. Next, let us see the problem for this circuit. So find the total resistance. If R1 equal to 6 ohm and R2 equal to 3 ohm, just calculate the total resistance. So you all know that formula for total resistance is 1 by RT equal to 1 by R1 plus 1 by R2. So here 1 by 6 plus 1 by 3. So 1 plus 2 divided by 6 when you take an LCM. So 3 by 6. So the value of RT here is 2 ohm. So this is the right answer. Next, let us see in this sum, the voltage given is 12 volt and the resistor given R1 equal to 6 ohm and R2 equal to 3 ohm. You have to find the total current. So you calculate the total resistance, that is 1 by R1 by 1 by R2, so that the RT equal to 2 ohm. You all know according to Ohm's law, I equal to V by R. So the total current is equal to I by RT, which means 12 by 12 is the given voltage, 12 by 2, that is equal to 6 amp. Next, let us see the problem number 3, that is current across each resistor. Hope you all know about the general formula for calculating the current according to the Ohm's law is I equal to V by R. So here the current flowing through each resistance. So I1 equal to V by R1. The resistor value of R1 is 12, 6. So the voltage across the resistance is 12. 12 by 6, that is equal to 2 amp. And I2 is V by R2. So the voltage given is 12 volt and the value of resistor 2 is 3. So it is 4 ohm. So now by calculating total resistance, which is equal to I1 plus I2, which means 2 plus 4, that is equal to 6 ohm. So the current across each resistor is 2 and 4 and the total current is 6 amp. Next, let us see the example with 3 resistor problems. Here R1 is 4 ohm and another one R2 is 4 ohm and R3 is 4 ohm. So 1 by RT equal to 1 by R1 plus 1 by R2 plus 1 by R3. So the value of the resistance, that is 3 by 4. By doing the LCM and reversing the value, it is 1.33 ohm. Next, it has supply voltage of 12 volt. So according to Ohm's law, it is I equal to V by R. So IT equal to 12 by 1.33 is what we found on previous slide, which is equal to 9 amps. So the current in each branches, that is I equal to V by R1, that is I equal to 12 by 4, that is equal to 3 amps. And next, let us see what happens if one branch fails. So if one branch fails, the component failure, a part of systems is breakdown, and there is an alternative path for a flow of current, flow of voltage, and that the system uses the other route function. And there is a continuous operation, whereas in series circuit there is no continuous operation. The flow has been stopped. There is no flow of electricity. So there is an isolated failure because only the failed components is affected, not an entire system is affected. That is the main advantage of this parallel circuit. So let us summarize. So the main advantage of parallel circuit is its fault tolerance, which means it prevents the circuit failure due to the single component issues, and it has decreased resistance. So reduce the overall resistance, and so that it increases the efficiency and the current divides. So it distributes the current among the parallel branches. And next is same voltage. Ensure the consistent voltage across all the components, and also it has a multi-path. It provides an alternative route for current flow. These are the general formula you have to need to remember when you calculate the parallel circuit problem. That is terminal voltages V1 equal to V2 and total current is summation of I1 plus I2 plus I3 and calculation of total resistance is 1 by RT equal to 1 by R1 plus 1 by R2 plus 1 by Rn. I hope you all understand this session. Let us go to the conceptual thinking part. So what is parallel circuit? You know about that each bulb is connected in separate branches across the same voltage source. And what happens when one bulb fuses? So when one bulb fuses, what happens? Circuit becomes open and the other branches remains complete circuit so that the current flows still through them. And why do other bulbs continue to glow? Because they still receive the full voltage supply, so they receive to glow. And what is the key idea of it? So the parallel circuit has a multiple path. So one path fails, the other path still works. Okay. How to ensure the continuous lighting in the circuit? So you have to, by using a parallel circuit, you ensure the continuous lighting. Whereas in series circuit, the system fails when one bulb fuses, the other does not have current flow. I hope you all enjoyed this session. If you have any doubts, please feel free to ask me. Thank you.